Hi, and welcome to SPE Live and today's exclusive interview with Andres Mantilla, Director, Ecopetrol Technology and Innovation Center, or Instituto Colombiano del Petróleo, ICP. It is one of the largest centers for technology development and innovation in Latin America. My name is Nils Kolkesenlo. It's my great pleasure to be your host today. SPE Live is in part made possible by sponsorship from the SPE Foundation. Today's SPE Live is part of our ongoing conversation series with senior executive management from the oil and gas industry. Now, on today's SPE Live, we are focused on oil and gas and green energy in Latin America. Colombia is recognized as being one of the most ecologically diverse and ecologically rich nations globally. It also has a long-established history of oil and gas production. And Ecopetrol, as the nation's oil and gas operating company, shoulders the responsibility of operating in this emerald environment. Andres Mantilla joins us today to talk about Ecopetrol's successes, technology innovations, and the road ahead for oil and gas in sustainability and the low carbon environment. Andres is the director of Ecopetrol's Technology and Innovation Center since 2013. He has more than 26 years of experience in the oil and gas industry. Andres is a specialist in subsurface data integration and modeling and technology management. He has worked for BP in Colombia and Marathon Oil and Maersk Oil in the US. He's a petroleum engineer from Universidad Industrial de Santander with a master's degree in petroleum engineering and a PhD in geophysics from Stanford University, a fellow geophysicist like myself. Andres, welcome to SPE Live. A very warm welcome to you.
Thank you, Niels. Thank you for having us, and thank you to SPE and the SPE Foundation for having these kind of events.
Oh, thank you. It's a pleasure to have you here. Now, just a quick reminder to our audience, if you're curious about the oil and gas technology development in Colombia and its wider impact in Latin America and globally, then fingers on buzzers and keyboards. Please type your questions and comments into the social media chat, and we'll pick them up as we go. Now, Andres, let's maybe set the scene. So Ecopetrol has made some substantial significant gains recently in heavy oil production. You've increased heavy oil production, you have reduced your operating costs, increased efficiency, reduced your carbon footprint in those production scenarios. Tell us a bit more about this as sort of a scene setting, if you please.
Thank you, Niels. So let me give you some history here, some context. At the end of the last century, this plot shows our production in the central Llanos area of Colombia, one of the most prolific basins that we have in the country. So this is combining production from the foothills area and also from the foreland fields. So as you see here, we were facing steep decline of production. The green area here is light oil from the Cusiana and Cupiagua fields in the foothills of the Llanos Basin. So a very steep decline we were facing back then. And that was just the production side of things. We were facing really difficult conditions on surface because of the internal conflict that we had at the time, which was probably at the maximum point of intensity back then, with very difficult conditions to operate. So it was very, very worrisome for the company and the country. And out of this graph, the other two colors are pretty much heavy oil, particularly this green one and the orange one here. This is a medium to heavy grade that is produced from the API field. And this is what we did. We started working on heavy and extra heavy oil. And over the next 2 decades up to now, we managed to reverse the decline in production output from that basin. And mostly, as you see here, it was achieved through increasing the heavy and extra heavy grades and bringing up new production from new fields in the area. But to be able to do that, we had to study heavy and extra heavy oil in quite some detail. And that is very important because, you know, heavy oil is just a very broad category. It has a lot of detail to be explored within it. And there are a different number of subtypes of heavy oil. And typically just, you know, API gravity, which is one typical measure that we use in petroleum engineering to decide what kind of production methods to use, is just not enough. And many times even molecular weight is not enough. So what we did is we chose to be very good at heavy and extra heavy oil production, transportation, and refining systems. And to do that, we had to go through, you know, years and years of very detailed characterization and research about the composition and the behavior of these heavy oils. You know, what kind of molecules, what families of molecules you have in heavy and extra heavy oil, what kind of compounds. They're very different compounds. You know, the typical wisdom is that you have asaltenes and resins rich oils when they are heavy, but within those families, there is a great deal of differences. So we went through very detailed characterization and understanding of how these systems behave really. And in some cases that they behave, for instance, when it comes to flow, they behave as a viscoelastic network, like in this picture here, but they can cluster and form aggregates that will precipitate out of the mixture and cause you a great deal of problems, as you probably know, when they become unstable colloids. And that knowledge allowed us to start developing technology for producing more efficiently these type of oils. For instance, here, I am giving you an example of chemical additives to reduce frictional losses and increase productivity. And we had to develop a solution for low water cut producing wells and another one for high water cut producing wells. And we carry the two of them now. Those have allowed us to save up to $45 million a year in the wells that we have implemented them, with the extra benefit, very important benefit, of reducing emissions, you know, up to 72,000 tons of CO2 equivalent a year. And then in some other example, we had to change the paradigm for dehydrating these type of oils, which typically are dehydrated using heat, you know, high temperature processes like, you know, heating up the oil up to 200 Fahrenheit, like in this example. And typically the system consists of, you know, a free water knockout where you separate free water and then the emulsion, the mixture, is heated and goes through some tanks where you allow it to reside until finally you get your export product. But since you're heating your mixture, your emulsion, then you are consuming some energy, some thermal energy, and that releases some greenhouse gases in itself, but also it produces some evaporation. And just 1% of evaporative losses that we had reduced the API gravity, you know, from 12.5 to 11.9, so half a degree. So you're losing product. And then that cost another issue, which is, it requires more diluent for transportation, because what you're losing is the light grades, the light fractions to the atmosphere. So what we did was we designed a chemically based dehydration process that eliminated heating. And by doing so, we were able to reduce another 36,000 tons of CO2 equivalent a year, and ended up with a better product, a little lighter product with benefits up to $45 million a year. Then when it comes to transportation, we had to, again, rethink our systems and change a few paradigms to be able to transport our product, our mixtures, our blends through pipelines at higher viscosities. And we achieved this through very detailed modeling in our labs and pilot plants, transportation pilot plants, to be able to demonstrate that you could handle higher viscosities. This is very important because these oils are produced, in a region of Colombia that is far away from the refineries and export terminals. So they have to go through a very steep mountainous chain, very steep range, which is the Eastern Cordillera of Colombia. And you have temperature changes in transportation that were very worrisome for the guys in the midstream segment of our company, because they were fearing, that the pipes will pack if you had to stop pumping and you would not be able to restart them. So we had to tailor the viscosity and the transportation conditions so that they were not, the blend was not too viscous so that the pipeline would pack during restarts, but they were not so light that you would have to add too much diluent, which is a very important cost in the cost structure of our heavy oil production. And by doing so, we were able to save $325 million a year and avoid another 12,000 tons of CO2 a year. And then in another example, by understanding the detailed composition of these heavy and extra heavy oils, we were able to better select the diluent that we needed. Because before, the decisions about diluent, since it's too expensive and it's a very important cost, like I said, were based on diluent price in the market. But it turns out that these are imperfect mixtures, imperfect liquids. So some things happen when you blend 1 barrel of heavy oil and 1 barrel of diluent. That's typically not 2 barrels, but sometimes a bit more than 2, sometimes a bit less than 2. So, and not only that, but also some types of diluents were more prone to evaporation. So by detailed study of the diluent and heavy oils and the mixture that they form, we were able to reduce evaporation and heavy oil contraction. And we were able to use locally sourced diluents. And that allowed us to save another 192,000 tons of CO2 equivalent a year and save close to $20 million a year in that other example. So what we've been doing really is to take a different approach to sustainability, not only in terms of efficiencies for the company, but also for typically environmental, social, and governance issues and our relationship with those different aspects of our operations. What we're doing really is to take a TESG approach, which means technology, environmental, social, and governance. And we're coining the term sustainability for sustainability. And what it means is trying to make technology an important enabler of all things ESG, all things related to our relation with the environment, the society, and the governance. And with governance, we're going even, way farther than just corporate governance. We're dealing with the governance and the sustainability of the territories and the regions where we conduct our operations. When we start factoring in some things like emissions within this approach, what I'm listing here is a number of different proprietary technologies that we've developed for heavy and extra heavy oil. And their benefit, their yearly benefit, as if we had no carbon tax. We currently carry a $5 a ton carbon emissions tax in the country. But we know that's going to increase. And you see that when you start factoring in emissions, then things start looking different. So if we had a $15 or $25 a ton, then what happens is you will have to prioritize differently your decisions. And that's very important, because that allows us to make decisions not only based on finance, but also on ESG or TESG.
Andres, thank you. I'm just going to, I think this is a really good point to sort of, ask you, because I really like the emphasis you're putting onto technology, leading, sustainability, and addressing, a lot of the climate issues that we're facing, particularly CO2. And what you've explained to us now is not only have you improved operational and production efficiency, but at the same time you reduced costs significantly, and you also reduced that carbon footprint piece. And just here on this graph, you're talking about the impact of CO2 taxes on operational decision making. So do you see this as a cost of doing business, or is this an opportunity to innovate with new technologies and to develop new business or product service lines?
I think it's both. I think it's both, really. So it will certainly allow us to reduce our cost. We've seen a great deal of synergy between reducing cost and reducing emissions. So that's one thing, but definitely if we tackle emissions, we will be able to open new opportunities when it comes to business. And let me show you something of what's coming for us at Ecopetrol. Because some of what I've shown you so far, it's our past developments. We're still working quite significantly in heavy and extra heavy oil, because we carry quite a significant production, about 450,000 to 500,000 barrels a day as a country. And that's a very important income stream for the company and the country. So, but going into the future, we are studying carbon capture using nature-based solutions, but not just the typical agroforestry project. We're studying native species. Like, for instance, in the Llanos Basin, we're going to study moriche. That's a native plant that forms an ecosystem that's very important for water preservation in the Llanos, but also mangroves in different parts of Colombia, and what their carbon capture capacity is really, because that's not typically well documented. And if you don't have good documentation about those systems, then you're going to have to make an analogy with some other ecosystem in some other part of the world. And what we know, for instance, when it comes to mangrove in these latitudes where we are sitting, is that their carbon capture is superior. So we're trying to first document that carbon capture capacity, but also developing methodology. So if you wanted to conduct a project that is going to grow mangroves or preserve them, you will be able to do that more technically. There's a great deal of technology going into that. And then we are also studying emerging technologies for carbon capture and sequestration, novel materials, and even novel processes that reduce the cost of capturing carbon from flue streams and chimney stacks. And because the established technology, the amines technology, is way too costly. It's about $100 a ton for capturing CO2. And, you know, if you're sitting in Switzerland, for instance, where you have a bit over $50 a ton of carbon tax, then you're still $40 away. Colombia is, of course, behind that. But we're starting now to be able to be ready for when that carbon tax increases, because we indeed think that's going to increase.
Andres, can I just ask you a question here, because I think you're touching on some really important and innovative topics around carbon capture. So you began talking about the nature-based solutions, and I think it's really encouraging. It reinforces Colombia and Ecopetrol's reputation for care of the environment. So you talked about the nature-based solutions, the mangrove swamps in particular, and then you've mentioned the more conventional sequestration through using novel materials. Can you say a little bit about, obviously there's a balance, so nature-based solutions are long-term, and the sort of conventional systems are shorter-term where we can convert carbon or capture carbon. What to you is that balance? Is the idea that in the long term you can be more reliant on nature-based solutions, or will there always be a drive and need for the conventional types of technologies as you were mentioning?
I think it's a combination of both, and I really think you're going to need carbon capture and sequestration, really, because nature-based solutions are great for the environment, are great for biodiversity, and even for, you know, securing food for people, because there is a lot of pollination that happens through these kind of nature-based solutions, particularly if you're using native species. And that is important for food security and also for water security. So that's very important, but that requires a great deal of land. And, you know, also land planning, which is, it's not a minor issue. It's a very contentious issue all over the world, and particularly in Colombia, it has been in the past. So, so yes, we need to do that, and it's very clever to do nature-based solutions, carbon capture using nature-based solutions, but you also need carbon capture and sequestration. Also because you still have the great emitters, right, in the refineries and the heavy industry. So you need to do something with those emissions. And really, one of the most effective ways of taking CO2 out of the atmosphere and bringing it either to the biosphere or the geosphere is really carbon sequestration. And EOR is an option. EOR is an option, and it has some synergies because it allows you to produce some more oil. So it has a better chance of being profitable as it is in the United States, in some parts of Texas, for instance. So definitely, if we manage to think about the entire system sources to sinks and find a match that allows us to make projects fly from the environmental standpoint, but also from the financial standpoint, then it will be great because it's a very efficient way of reducing emissions from the atmosphere.
Okay, thank you. So, and there, yeah, I mean, earlier you mentioned also the advanced materials that you guys are developing in terms of that electrochemical swing reactive absorption technology, if I got that right, to help capture CO2. So that's again part of your technology center's innovation piece. So that kind of reminds me of our earlier conversation where you were also talking about water treatment technologies, and you have it listed here on the slide. Tell us a little bit about your focus on water technology and so, how it relates to oil and gas production in Colombia.
Yes, so we carry a few fields which are more, water-producing fields than oil-producing fields with water cuts, over 95% in some cases, in many wells. So we have developed systems for separating free water and cleaning it really well in a very compact form. And that's very important because the land footprint for those systems, but also the capex for those and the opex for those is way superior to what you typically encounter in the industry. So we're from that baseline of the compact water separation, water separation and cleaning systems that we have developed so far, into things like leaving water in quality levels that is compatible with the environment, so that you can use it with ecosystems like those nature-based solutions, but also you can provide it to some other industries that surround you. And in Colombia, that's typically agri-industry. So we are working together with different types of agri-industry companies, producers, for instance, of palm oil, and we are approaching some other producers to see if we can reuse that water that we take out from the subsurface. So after cleaning it very well, of course, we think that is doable. We have conducted a pilot that has run for about 8 years now, where we have tested all things related to productivity of the land when we irrigate it with this water, but also ecotoxicity and the impact on species, everywhere from the very, very small species all the way up to big animals like cows, for instance. And we have found that you can do that successfully. So, and why not? Maybe in the future, treating residual water and offering it for communities, making it portable. So those are some of the things that we are working on right now and into the future.
So that's really great to hear. I mean, that sort of speaks to that circular economy piece around water management, and water is such a critical resource, as you were mentioning. I guess a really important question around produced water is its salinity. So can you say a little bit about how saline your produced water is, and how you treat saline water?
Yes, and we carry, a great diversity of formation waters when it comes to salinity. Of course, the easiest to treat is the fresher water that we have in parts of the Llanos Basin, for instance. And but in the Middle Magdalena Valley, we carry a bit saltier waters. I wouldn't say it's very salty brines. Of course, they are not, but they are treatable and they are reusable. That's what we believe. So, but I wouldn't deny it. The easier ones, of course, to deal with are the fresh waters that we carry in the Llanos Basin. We have some dissolved solids there, some ions to deal with, but the most difficult piece is to deal with the oil components, because those are typically related to the heavy oils that I was talking about, and those heavy oils are very surface active. They have plenty of surfactants, polar compounds that make emulsions very stable. So it's quite difficult to remove them and to do the fine cleaning of the water to achieve it successfully. So that's one of the aspects where we specialized, really.
Okay, thank you. That's good to know and very interesting to hear. I mean, obviously that difference in water quality, salinity in particular, is an important factor in how we treat produced water. I'm just going to turn our attention a little bit to some comments from the audience. So it goes back to the heavy oil production piece. So heavy oil production and CO2 sequestration. So first of all, Jose Magoyan on YouTube, he is saying sequestration is very important. Using an EOR would be great. And I guess his question really is the distance between the reservoir and where the CO2 is produced. So you were mentioning earlier that, there's a lot of terrain difficulties in Colombia with the mountain ranges. How are you as a company looking at can you connect CO2 injection with carbon capture? Is that possible, or are they two very unrelated problems?
Yeah, that's a very, very important aspect and a very good question. So you really have to think about where the source and the sinks are, and the cost of bringing the CO2 from source to sink. And in many cases, you get co-location. For instance, we have quite a few depleted oil fields, existing oil fields, close to the refinery that we have in the Middle Mag, in the city of Barrancabermeja. Very close to Barrancabermeja, there are plenty of oil fields where we could sequester CO2. And then you have, a very obvious case for trying to attempt carbon capture and sequestration. And that refinery is an important emitter of CO2 because we have to hydrotreat our fuels to remove sulfur from them and make them better quality fuels. And hydrogen production thus far is, it's conducted by methane steam reforming, and that is quite prone to generating emissions. For every ton of hydrogen that you produce, you typically produce 10 tons of CO2. So that CO2 is typically a fairly rich stream when it comes to CO2 concentration, and it will require less treatment, if you wish, less conditioning to bring it into EOR and sequestration. In some other cases, in fields, for instance, in the foothills, we have gas plants that are also important emitters of CO2. And we have the fields right there with very steep dips that you can probably do carbon sequestration in them. In some other cases, we have depleted gas fields, but those are not so close to where we have the main emitters in the country. So, and in some other cases, we're studying what kind of infrastructure is already in place. In some cases, you have gas pipelines that you could potentially use to transport the CO2 from those emitters back to the fields that could store the CO2. But that's definitely a point that you need to consider when conducting these kind of projects.
Yeah, absolutely, and it's good to hear that you have at least ideas or solutions for how you can connect the emitters to the sequestration reservoirs, if you want. So, I mean, it's a struggle for all the industry at this current time, is how to connect those two. You mentioned hydrogen, and I want to turn to that shortly. There was just a couple of other good questions around the heavy oil and the water treatment. So first of all, the water treatments, it was John Pedersen, I think, on YouTube. He was asking, are you using reed beds or wetlands for processing produced water? You mentioned some of these nature-based solutions there. So is that part of your strategy to use the wetlands to treat produced water?
It is not at the moment. We're not using wetlands for treating our water. Like I said, what we have developed is a very compact system that separates the water out and cleans it really well, so that you can re-inject it back to the subsurface. At the moment, that's a developed technology, let's say. But like I said, we're working on very fine cleaning of that water to make it compatible with the environment and with agri-industry at larger scales, let's say, because I said we have conducted a pilot over 8 years of doing that. But we're bringing that to industrial scale, if you wish. When I say industrial scale, I'm talking about 1 million barrels a day, and that doesn't use wetlands. We are thinking about wetlands, but more for carbon capture in nature-based solutions, because that can be an option as well. But at the moment, we are not using wetlands for cleaning our water.
Okay, thank you. That's a good response there. Before we turn away from heavy oil, so there's been several comments about heavy oil production and its relative importance to the sort of more conventional light oil production. Why is heavy oil production important?
I'm sorry, can you repeat the question? It was cutting a little bit. It was breaking.
There's been many comments around heavy oil production. Why is it important? So why do you continue to produce heavy oil when it is such a challenge in many ways? You've been very successful in producing it. So why is there a market for heavy oil?
Well, you see, heavy oil is quite important for society. When you think of roads and asphalt, well, that comes from heavy oil. And it's very important for infrastructure construction, but that is past and present, and it will be part of the future as well. But really, heavy oils are very rich in a number of different kinds of molecules that can be very valuable. Molecules that can be the raw material for advanced materials, high value materials that we are also investigating. We're conducting quite some research on how to take those heavy molecules, those long molecules that tend to have aromatic cores of different sizes. That's one of the important differences when it comes to heavy oil, how big the aromatic cores really are, and they differ very greatly even within a single basin. And you can take those and make quite a number of valuable products out of them. So we're thinking about heavy oil, not just in terms of efficiency as we've done in the past, but also in terms of advanced materials, high value added materials that we can produce from heavy oil.
Okay, thank you. So just quickly on to turn our attention briefly to hydrogen. You mentioned hydrogen earlier relative to the refinery and steam reformation. What activities and innovations does Ecopetrol have around hydrogen production?
Yes, so we conducted a technology monitoring study last year. That was 2019, and this year we matured a study and started the first activities of a study that will take us to conducting a few pilots for hydrogen production from electrolysis, and that can be in the future, a competitive way of producing hydrogen from renewables. So green hydrogen, as it's called in industry, as opposed as gray hydrogen from methane steam reforming today, which releases quite a lot of CO2, like I said. So we are going to conduct a few pilots for hydrogen production from electrolysis tied to some of our refineries, and then using that hydrogen for different applications. And if you're in a refinery, well, you need a great deal of hydrogen for, like I said, removing sulfur from your fuels and making them better quality and more compatible with the environment. But also we're going to look at mobility, hydrogen applications for transportation and mobility, where there seems to be a niche for decarbonizing heavy transportation, heavy trucks for long distances. That doesn't seem to be doable with batteries. And also, for some other heavy industry applications, just the typical ways of electrifying those industries just wouldn't do it because of the high heat involved in the processes. So we're starting to look at that, different types of different alternatives for producing hydrogen, not only electrolysis from renewables, but also compact methane steam reforming, which could decentralize hydrogen production. And that would be very important because we see gray hydrogen with tied to carbon capture, and then it will be blue hydrogen because you're capturing the emissions and sequestering them. We see that as an alternative, as a transition alternative into a future that is fully decarbonized when it comes to fuels. So it's really something that we see coming. It's going to take a few decades to develop it, but we're starting now because we want to assess whether or not we should be a player in hydrogen.
That's a very refreshing perspective, because I mean, what we hear so much of in the energy transition debate is electrification, and everything has to be electrified from solar and wind. And you're actually advocating, in a way, an alternative is that the future may be more dependent on hydrogen. And I guess that may also reflect Colombia's topography, as we talked about or mentioned many times. You have significant terrain to deal with, which obviously influences how easy it is to build out infrastructure. So I think that's certainly a very interesting perspective of how you want to make smaller technology that's more mobile and easier to place out in remote locations, I guess. So very, very interesting perspectives. Ecopetrol's done a lot of really good innovations. So how does Ecopetrol partner with other oil companies, service companies, and technology companies? How would people want to partner with you? How can they partner with you to take some of this technology and transfer it to other places globally where they have similar challenges?
Yes, we're very open to partnering. We have had successful partnerships with both international and national universities and tech-based enterprises. We tend to hear a lot from people trying us to test their technologies, and that's quite interesting. But really, to be quite frank, it has to be technology that is very synergic. It's closely linked to our strategic goals, because we have a clear vision of what we want to achieve in the future, and we just don't like to be diverted from those goals that we have, because resources are always limited. So we're very open to partner with peers, EMP companies, service companies, you name it, small enterprises, even startups. We have partnered with some startups to, for instance, to develop components of that compact water separation and cleaning system that we've developed. And this is just a startup of 5 people that just came out of school and won one of our open innovation challenges that we carry. So we're very open to that, and we will be more open in the future to do that. I think really that to address the big challenges that we face as a society and as an industry, we really need to partner, and we really need to complement our abilities with those of others. We've been an EMP research and technology development center so far, not really an OEM. That's not our DNA. I'm sorry. But we're very good at taking a systems engineering view about problems and trying to solve them. And what I mean by that is thinking about all the implications upstream and downstream from where you're trying to introduce the technology to make the technology implementation successful. So yes, we're very open to partnering.
Yeah, that's great. A very welcoming message there from you, Andres. So thank you for that. And hopefully the audience will benefit from that, and also they can watch this interview with you on demand afterwards as well. So all this is available to the audience for free. We are sadly out of time. So Andres, thank you very much for sharing your perspective on Colombia, Latin America, all the great work you guys are doing on heavy oil production and how you're stepping forward into carbon capture and sequestration and hydrogen. So thank you very much. And also water, I mustn't forget the water, because that's a particularly important part for our industry. So thank you very much for sharing everything today. It's been a pleasure talking to you, Andres. Thank you very much. And thank you to the audience. Great audience questions and comments. Thank you. Keep those coming. We have more SPE Live next week. We're turning our attention to digital transformation and production optimization. And if you're new to SPE Live, then find us on #SPE Live or on SPE.org. So Andreas, audience, thank you. Everybody have a great day. And we'll see you soon. Thank you.
You too. Thank you very much.